So I think it's best to sort of start out and talk a little bit about why we might need scalability. So I think it goes without saying that this blockchain area has garnered a lot of interest. We're all here. Some of us have dedicated many, many years of our lives to advancing this particular technology. And the reason for this is because the technology really does have really does promise a complete revamp of the way we do business. And I mean this in two different ways. One is, it's very clear to me at least, and many other technologists who have been working in this field, that the back offices of most companies will have to be redone to accommodate blockchains. The way we do, whatever happens in the back office is going to have to change. It's going to change because the new revamp is going to give us better efficiencies, it's going to get rid of reconciliation, it's going to give us transparency, and it's going to give us a huge set of features that we did not have before. So this is interesting. And if it were only this, then we wouldn't be having this conversation right here. We would be having it over in the CS building. It would be a geeky endeavor. It would be more like people like me and less people like we encounter in Wharton. So there is more going on here than just the geeky back office. What's going to happen as we switch to blockchains, and especially as we switch to smart contracts, which despite their name are neither smart nor anything at all like the legal contracts you're familiar with. They're more like programs that determine where money goes. As we switch to these technologies, there will be new business models emerging. We'll have companies that do business primarily on a blockchain. We'll have companies without custodians. We'll have companies without representatives. We'll have trustless commerce. And this is a fascinating field. It's an extinction level event for many incumbent companies. So as we switch to these kinds of new applications, these kinds of new domains, we will find that to actually facilitate commerce between programmatic entities, especially between programmatic entities, but also even between humans. So there's I think maybe for the non-technologists in the audience, they might not understand the enormous difference. So there are about a few billion humans on Earth. And if they start actually transacting, they will demand quite a bit from the underlying infrastructure. But as we switch to machines transacting, then there is going to be many orders of magnitude added on top. And in such a world, you need the infrastructure to be able to facilitate the transactions between these entities. So the scalability problem is real. Now, why is this a problem? Can we accommodate this in some other fashion? Like, well, why is this technology limited? Well, fundamentally, in all of these blockchain-type technologies, you typically have some shared database that is in common between multiple entities. Now, whenever you have a single machine, then that's an easy case in computer science. We know how to update data stored on a single machine. But when you have more and more machines, we run into what is known as the consensus problem. And the consensus problem has to do with keeping these machines in sync. It might seem like a simple thing to you. Essentially, it seems like, well, what's the problem? You get it's like getting a bunch of people in a room, and you just tell them something. And then whatever you told them, that's the last state of the record. Well, it doesn't work that way between machines. And I'm sure you've run into situations where you have a bunch of people in a room, you tell them something, somebody else tells them something slightly different, and then there's discrepancies. And then once they start, then they multiply and amplify. So the problem of keeping machines in sync is actually very, very complicated. It's subtle, and many careers have been spent, and some careers have been completely misspent on slightly incorrect implementations. I have a colleague who spent 2 decades on a broken consensus problem, or rather, a broken consensus protocol, without realizing his own error. So these things are subtle and difficult to get right. And the other problem, of course, is not only the correctness, but the performance. When you have multiple machines, especially if they're geographically far apart, it takes time to update them. So the scalability problems that we see with the first set of blockchain technologies, the public blockchains, for example, with Bitcoin, are quite real. Bitcoin Core got limited to essentially 3.5 transactions per second for the vast majority of its lifetime. Even today, it's achieving, well, today actually it's achieving less than 3 transactions per second. The usage has dropped, but it can achieve about about maybe twice that. So if you think about what that means, let's say 5 to 7 transactions per second, I think that's about roughly the number of cars going into and out of Manhattan at any one time, or a bunch of IKEAs on a busy Saturday. That's not much commerce. That's not how you tackle the needs of the next generation. If Venezuela were to switch to Bitcoin today, every adult Venezuelan gets to trade, gets to perform a transaction once every 36 days. You buy a packet of gum, you're done. Okay, so you get to sit at home for 35 days for your next shopping trip. So clearly, these technologies need to scale up somehow, and there's much to do on that front. So there's technologically a lot of development that needs to happen.
Yeah, and so one of the key things I think about this is that as we want more decentralization, right, just throwing more computers or more nodes into Bitcoin doesn't actually solve this problem, right? If you want to keep decentralization, the more participants you have, it almost gets worse.
Absolutely. Right? So the bigger the networks are, the more popular they are, the bigger the scalability problem is going to be.
And so then in terms of the solutions that we've kind of seen as Bitcoin has tried to scale, can you talk a little bit about some of the things that they've tried to do with Bitcoin Cash or other types of sort of patches that people have gone through as we've tried to come up with a longer-term solution?
Sure. Maybe I can talk a little bit more broadly about how to handle the scalability problem. There is the particular history of Bitcoin itself, but I'd like to take a step away from that and sort of look more academically, perhaps, at the bigger picture. So what we are really seeing with these new blockchains is the emergence of a new software stack. So when the internet came about, we just essentially first just had wires, then some custom monolithic software on the endpoints, followed by what we call the OSI model for the internet protocols. It's layered architecture. You all have heard of TCP/IP. Well, those are two common layers of that 7-layered architecture. That took some time to develop. And we're currently in the midst of developing such an architecture for blockchains. And at the very bottom of this architecture lies the network layer. This is an often misunderstood, often overlooked layer that we haven't really fully pushed to its limits. Above that layer is the all too well-known consensus layer. That's the layer at which the blockchain is making decisions. Above that layer is the smart contract layer, and above that is the application layer. So we really need to think broadly across all four. And the bottommost and the topmost layers get about the least amount of love at the moment. But the scalability bottlenecks, as of today, lie at the lowest 2 layers. So maybe we can talk a little bit about those. In the network layer, we have the problem of getting data from those people who have it to those people who demand it. So in Bitcoin, these are transactions that people inject into the network, as well as the blocks that miners discover that add a page to this distributed ledger. So somehow this data has to fly super fast from the people who have it to the people who are going to build on it and use it. So we're currently working on a series of technologies on this front, both the developer community and the research community. My own group has come up with something, and in fact, I actually have a startup based on this called BlocksRoute for sending data very quickly from sources to sinks. And there's a lot to do here because essentially what we're dealing with is an overlay network on top of the public internet. And there's quite a bit one could do that is far better than what is done today. The common thing that's done today is I tell you something, you check it, you forward it on, and so forth. And you could imagine how long it would take for that data to get from here to the back of the room. It would approximately take logarithmic in the number of people in the room is actually the correct answer. But it would take, I would say, what, five or 7 hops, right? And that's actually quite a bit of time. We can bring that down to much, much, much less than that. We could actually get rid of that logarithmic factor. So that's an exciting area that's been overlooked, and we're currently working on it. There are also compression technologies, coding technologies. You could encode the data such that I give you a little bit at a time, but even if you were to lose some of it, you could still reconstruct it. So these are techniques that you would know well. So on top of this layer is the consensus protocol, and there is much to say there. So let me try to sort of lay out the field. You've all heard of the following framework. And I'll give you two phrases: public blockchains and public permissionless blockchains and private permission blockchains. How many people have heard of these terms? Everybody. Okay, so that's one framework. And in the early days of any technology, there emerged certain narratives that sort of spread like wildfire because they capture the zeitgeist, but they are not necessarily comprehensive. Okay? There are many, many more architectures to the consensus layer than what you have heard about. There are many more models to building blockchains than these two. So what we're looking at right now is if you look at actual credible designs for the consensus layer, there are many different architectures. If you look at Bitcoin Core versus Bitcoin Cash versus Ripple versus ADA versus any one of the sort of the IOTA, if you will, Hashgraph, Algorand, etc. If you look at any of these newly emerging consensus layers, they are actually quite different from each other. We don't actually have the consensus protocol set. We don't have the consensus models set yet. So I think, personally, I am very, very excited about the consensus layers to come. I suspect that, we can go into the whole permission debate and so forth. I suspect that what actually takes off in industry is going to look nothing like the models that we see today. But at the core of this whole like search for a new consensus protocol lies this desire to come up with a new protocol or some kind of a consensus protocol that's fast, scalable, low latency, that gives you high security. And it's a little difficult to get all four of those into the same package. But it's not impossible. And if anybody tells you it's impossible, it's often, so for people in my position, it sounds wise to say things like, well, there are always trade-offs in distributed systems, da, da, da. Well, there are some trade-offs, but there are such things in this particular domain. There are no impossibility results. And it's possible for new protocols to emerge that are strictly better than everything that came before them. Okay? So I want to give you some rays of hope. And don't buy into any narrative that tells you that, oh, you have to give something up to get something else. You don't have to. Yes, with the current Bitcoin protocol, for example, there is a trade-off between centralization, that is lack of security, if you will, and performance. But there are other ways around this. There are many other protocol suggestions that have been proposed, also some from my group, but from others as well, that don't have that particular inherent trade-off in them. So we're living at a very exciting time. That consensus protocol layer is being worked upon for building chains that are scalable, fast, as I said, low latency, and high security. And then finally, at the layer above the chains, people are working on what are called layer 2 solutions. That is, how do we take the loads off the chain? Is there any way that I can perhaps reserve some assets on a chain, convince you that I have reserved them, and then engage in transactions with you on a peer-to-peer basis without having to update the chain itself? And then we can net or settle on the chain later on. And so that, of course, gives us that extra leverage. If the chain can do X transactions per second, well, we can do Y among ourselves. Well, then suddenly we have an enormous multiplier in what we can do in aggregate. So these are very exciting sort of areas. I hope I tried to sort of lay out the land for non-technologists. There are 3 different layers to tackle the scalability problem, and we need to attack all 3 if we want to really reach these high multiples that we need to when we go to push this technology to all embedded devices.
Yeah, so I think some of these things you've touched on, like these layer 2 solutions seem like a shorter term kind of issue. You have an existing blockchain that works and it has some scalability issues, and you'd like to say, well, can we just use this as minimally as possible and build structures on top of it that allow us to sort of transact at the speed we'd like to, and still sort of bootstrap up a little bit of the security from this slower existing chain. But then sort of going down to the consensus mechanisms, I'm sort of more interested in that. And so I'd like to hear a little bit more of your thoughts there. And so some of the issues, like you talked about saying that there's, don't believe people who say there's trade-offs. I think one of the reasons people think there are these kind of trade-offs is that if you really want full decentralization, right, if everybody in this room is only going to talk to each other in point-to-point channels, and we have to agree on something, the more people there are to talk to, right? It grows quadratically, the number of just communications that have to happen. And so a lot of the solutions that have been sort of proposed is saying, well, let's sort of move to some kind of more centralized, right? You reduce the number of people involved in the consensus, or you have some kind of local transactions or sharding or something like this. And so people think that these solutions then do require some kind of trade-off. It's not that there's an inherent thing that all solutions have to require a trade-off.
Right, there is a nuance there.
Yeah.
There are trade-offs in protocol design,
Yeah.
right? So protocol design is all about finding the right mix, finding those properties that you can weaken ever so slightly and get a big leverage with. And in fact, we can talk a little bit about maybe Satoshi's genius. So for many years, academic computer science worked on consensus protocols with 100% finality. So that is, I give you, I give you a transaction. There's some set of validators that agree, and when they agree, it's final. There's no going back. So that's great to have. Except these protocols are very difficult to make open. It's very hard to have open membership. Satoshi's genius, if you will, and it took some time for the CS community to extract this, but once I say it, it's going to be obvious. Satoshi's genius, the reason why his consensus protocol became open is because he said, look, we don't have to have it with 100% finality. We can have it with 100 minus epsilon% finality. Now, those of you who know math know that there's a huge difference between 100 minus epsilon and 100, right? But those of you who are numerate also know that for practical purposes, if you have control over epsilon, they're pretty much the same thing. So in Bitcoin, for example, the ledger itself can get reverted with some probability, but it's so minuscule and it's so under your control that it's not a problem. So suddenly, what seemed like an impossibility with that technology back then for the first few decades of consensus protocols became a clear, easy to solve thing. And so when we encounter situations like this, for example, what you said, that is, in a room like this, can we have consensus without n squared connections? There is no impossibility result that says that you cannot. So it doesn't have to be quadratic. We can actually take that down, maybe. And I'm very excited about the research that we have in the pipeline on fronts exactly like this. So we've also been seeing all sorts of other sort of innovation at the protocol layer, at the on-chain layer. So my group, for example, played a big role in trying to make Bitcoin scale on-chain. And we devised a new protocol called Bitcoin Next Generation, Bitcoin NG. And the core idea there is to slightly change the way the blocks are structured. So now maybe I should talk a little bit about, I'll give you the 1-minute summary of 2.5 years of civil war. So those of you who know anything about Bitcoin might have heard that there was an enormous fight over this one parameter called the block size. So these technologies are all things where you add a block to the end of a big blockchain, kind of like a page to the end of a big ledger, and there is a particular size to that block. So there's a particular maximum size. And now, what should that size be? Should it be 1 megabytes, as it has been, which limits us to 3.5 transactions per second? Or shall we make it a little bigger? What would happen if we made it 2, 4, 8, 32, etc.? So this was an enormous, enormous fight. And the developers who are approaching this from the point of view of, well, we have the protocol as given to us by Satoshi. Where do we tweak the parameter to?
And can you just say a little bit? So as you increase the block size, you can put more transactions in, and so you can get more transactions per second.
Exactly.
But there's the trade-off.
Yeah. But as you make the blocks bigger, then miners who are centrally located, miners with greater resources, have an advantage. So if I have an enormously big block, those people in the back of the room will take a while to hear it from me, and they will forever be behind the rest of the network, whereas Brett would be in a prime position. He would have a structural advantage compared to the miners on the edges. So that is a protocol with an inherent trade-off. And so this battle was going on, and it cost a lot of careers and a lot of big fights, actually. And my group came in and said, look, there are different ways of structuring blocks that don't involve this trade-off. You are not stuck to this parameter choice. We can restructure the way blocks are discovered. Instead of coming up with one giant block at a time, why not elect somebody to be a block leader and have them mint the block piece at a time over time. So instead of going into this mad rush every 10 minutes when a block is discovered, instead of having to scramble and spread this block around as quickly as we can, why don't we just sort of turn it around its head and we slowly dribble the block out over time as new transactions are added to it. And we get a whole lot of benefits from this. And of course, we retain also the mining infrastructure. We retain all of the current decentralization. So all it takes in these technological endeavors is somebody who looks at the problem slightly differently. And I expect that we'll have many different consensus protocols coming up. We already have seen quite a few. And they will all have interesting features that improve on the current state of the art. So we are far from having established the stack. So going back to my earlier point. So given the way the stack is today, yeah, so there's this sort of, you get the current, the narrative that you see with the permissioned and versus permissionless chains, and the current problems and limitations. But it's best to not get stuck on those. And it's crucial to try to keep one's company or one's endeavors in this space nimble, because the underlying architecture is changing quite a bit.
Okay, well, we're actually almost out of time, it looks like. So can we take just one or two questions before over there?
New platforms like new protocols like Hashgraph and Cadena and some of these others versus some like Cosmos, for example, that is more focused on interoperability as it relates to scaling. If you have a view, maybe you can comment on that.
Sure, I have a view on every one of those, except if I were to share it with the crowd here and somebody tweets it, then I'll sit. By the time I sit down, all of the trolls will have descended on me. Let's be careful here. So maybe I'll generically answer the question. What you're seeing with Hashgraph and a bunch of others especially are ways to rethink the blockchain entirely. And this is great. It's very healthy. We should see more of these. Why should the entire world be a single linear ledger? It doesn't have to be. You could make it a graph. If two things are not dependent on each other, there's no need to order them. Ordering is what's the costly effort in any of these blockchains. But there are many, many ways of sort of doing design by gut feel that may or may not yield a correct protocol. So it's essential in this world to ensure that the proposed systems come with a proof of correctness. And you have to actually scrutinize the proofs of correctness, because there might be hidden assumptions in the proofs that are difficult to actually ensure in the practical world. So I'll say that. I'll also point out that I've seen many, many systems whose claims did not hold up once subject to scrutiny. I very much favor the current mode of writing white papers. That's wonderful. I have not seen that before in tech, where a tech company not only comes up, but also comes up with some technical paper that describes the innovation at the core of their business. That's great, but we should hold them to better scrutiny. So many of these white papers, if you really read them properly, they just fall apart. So I'm not going to name any names. But it's correct to say that at least 95% of the consensus protocols I've looked at break down or have a clear false claim. So I'll leave it at that.
Here.
You were saying you think off-chain solutions are more of a short-term scaling opportunity. Do you think eventually there will be a consensus mechanism that can handle the amount of transactions, or we'll have to continue off-scaling and reverting some of the data to side chains?
So I personally think that we should be exploring both. We should explore both layer 2 solutions and on-chain scaling solutions. Will layer 1 be sufficient? I don't see, so currently, if I look at the demands of layer 1 right now, we're actually doing okay. So tweaking the parameter will give us some breathing room looking at all of the commercial activity across all chains. So we could probably tweak it a little bit, and a little bit for the next couple of years. Now, what happens after that is a function of technological progress. If the networking folks give us better, faster speeds, then maybe we'll be able to tweak it more and more. But it's clear to me that we will reach the limits, that just tweaking alone will not get us to where we want to be. That is, on-chain scaling the way we do it with our current protocols is not going to be sufficient. So that motivates either better, for example, sharding on-chain, or taking some of the load off-chain. So for people who don't know what sharding is, it is the concept of a blockchain that has been divided up somehow. That is, if instead of keeping track of a single chain with everybody's transactions in it, I kept track of two chains, one for people whose last names start with A through L, and another one for M through Z, well, then I could suddenly double up my speeds, because a given node need only follow one or the other. Of course, now you have the problem of coordinating across the two ledgers that you have. But that's the core idea in sharding, and that might also give us a couple of multiples.
All right, well, thank you. Let's please join me in thanking Professors Emin and Brett Falk for joining us this morning.